Welcome! In this series of short videos, we will look at topics for the PowerBasic Console Compiler. Today we will look at how we can use the console commands to create a forms application. We have, in past videos, covered the PowerBasic Windows compiler to create forms. If in your application you're going to be doing a lot of forms handling work, the Windows compiler is ideal for this purpose. However, if you only have the console compiler, there are a number of console commands that can assist you to do a type of form within the console compiler itself. And that's what we're going to look at today. We're going to create an application which can be used to display a form to our users. Rather than to design an application specific to a particular form, we're going to create an application which can be driven by a form whose definition is held in an external file. So first, we will create in Notepad an external file. So this is going to be the definition of our form. We will create a title for our form, which the user will see at the top of the screen, and we now want to create a number of fields into which the user can actually type data. So we'll start with a very simple form with only 3 fields: first name, surname, and age. In our format, we're using the square brackets to define the beginning and the end of a field. So the first name and surname are the same length, and the age field is just 3 characters. So if we save this back to our folder, and we'll call this file form1.txt. So in our code, we will define a constant for the name of this file, form1.txt. And we're going to put most of the code in the pb main function. Normally, I avoid putting a great deal of code in the pb main function and prefer to call either functions or subroutines. But since this is just a demonstration of what can be done in the console, we'll leave most of the code in the pb main function. So we're first setting the color for the foreground on our console. This to be a light green color. So we're defining 2 variables to determine just how big our console is at the moment: column width and a row height. And we're using the conscreen command to populate those 2 variables. Next, we want to read the file we've just created with our form definition into an array. So let's dimension that array and then call one of our common functions in the pb file handling routines library to load that file into the array. So the read the file into the array function takes 2 parameters, the first being the name and the path to the file you wish to read, and the second is the name of the array you wish to populate with the data coming from that file. If for any reason we could not read the file, then that function will return a false. So now that we have the definition of our form loaded into the array, we now want to display that form on the screen so the user can actually see it. So we're going to declare 2 more variables to say where we want the beginning of that form on screen to be. So we're going to use long row and long column, and we're populating those with the values 1 and 1. This will be the top left-hand corner of our console. We can then place the cursor of the console at that location using the con.cell command. Next, we want to display the form on the screen. We'll call a function to perform this task. So this new function is going to take 3 parameters: the row, the column, and the name of the array containing our data. So let's go and create this function. So here is the skeleton of our function taking the 3 parameters. So we will first capture the size of the current console using the con.screen command we used earlier. And we're going to use an additional variable, long R, to step through each of the rows on the console. So we're going to do a for next loop for each row in the console to see if we have a corresponding row in our array. And if the row we're dealing with is greater than the size of the array, then we can exit the for next loop because everything has been displayed. Otherwise, we can use the con.cell command to set the cursor at a specific location on the screen. This will allow us to display each row in our configuration form file on the console. And that can be quite simply printed to the console using the con.print command, with the semicolon in the end to ensure we don't put a new line character at the end of the line. So now we have completed the display form function, let's see if it works. If we go back to the PB main, after we've displayed the form on screen, if we do nothing else, the application would terminate, but we want to leave it on screen so we can see what it looks like. So we will inject a wait key command just to ensure we wait until the user presses a key on the keyboard. If we try running the application now, we will see we get the form displayed on the screen. Now the cursor at the moment is sitting at the very end of the last row. So if the user is going to be entering any data into this, we'll want to set the cursor to the first editable field. So at the moment, the cursor is flashing at the end of the last data we displayed on the screen. We'll want to position this cursor at the beginning of the first field on the form. So that is our next task. So we're going to create another generic function whose job it will be to position the cursor at a specified field. So we'll declare another variable to hold our field value. We'll set the field value to 1. And we'll call our new function positionCursor, taking its two parameters, the first being the array and the second being the field we wish to actually put our cursor in. So here we have the skeleton of our new function positionCursor, taking its two parameters. So now we want to read through the information that sits in our array to figure out where the first field exists. This function will be quite generic, as you can put in any field number. So if you wish to set it to the third field, you could just substitute a different value of long field. So we want a for next loop. This is going to step through each record in the array. And we're going to need some local variables to help us keep track of this. So we're picking up the value that's in our array into the row variable. We now need to check to see whether this has got a field in it. As we saw from the definition of the form, the first few lines are pure text, and we know each of the fields has a square bracket as the beginning and the end of the field. So we're looking to see, has the row got a square bracket? In this case, an opening square bracket which tells us the position of the beginning of the first field. If this returns a value greater than 0, then we've found a field, so we can increment our field counter. And next we want to check to see if that field counter matches the field that the user has passed in on the parameters list. If that matches, then we've found the field we're looking for. And we're going to use the con.cell command to position our cursor. We're using the long position +1. Long position points to the square bracket. We want the cursor to appear to the right of the square bracket, and we're marking this as found. As we've found the field we're looking for, there's no point continuing with a for next loop, so we can use an exit for command to exit out of that loop prematurely. There's always a possibility in code that the programmer has actually asked for a field which does not exist in our form. If that's the case, we want to set it back to the first field, on the assumption that whoever designed the form has at least put one field into the form. We can do this quite easily by recursively calling this function again, passing in the parameter of field number 1. So having completed this function, this should now position our cursor at the beginning of the first field. Let's try running the application and see how it looks. As we can see, the application now has the flashing cursor at the beginning of the first field. Our next change to the application is to allow it to accept keystrokes from the user's keyboard. Some of these keystrokes will be to enter data into the field. The user will quite obviously want to navigate around each of the fields, possibly by using the tab key, the down or up arrow keys, and backspace and possibly delete to edit data. From the application's point of view, you don't want the user backspacing over the first name text, so you want to limit the user's interaction to the fields themselves. So let's have a look at the code to see how we could achieve this. So we need to have a way of trapping key presses that the user has actually made, picking them up, decoding them, and acting accordingly. So we're going to use the wait key command to pass its value into a variable, and this will run as a loop. The wait key command will return the keystroke pressed. It will wait until that happens, and will return either 1, 2, 3 or 4 characters. In this video, we're only going to be handling the first two characters. Characters 3 and 4 would be if the user actually uses the mouse. We'll possibly cover that in a later video. So having populated the input variable, we're now going to use a select case statement. We'll handle first of all the pressing of a single key. With any of our applications, we need a way of actually exiting the application. So we're first of all going to capture the escape button. If the escape button is pressed, we will exit the loop and terminate the application. We can determine the escape button has been pressed by using a Windows API call. And that call is called getAsyncKeyState. It takes a single parameter, which, as you can see, is a constant called vkEscape. These constants can be found in one of the include files that ships with PowerBasic, in this case the winuser.inc file. And we can see in here the value of vkEscape. But having these defined as constants makes the code more readable and saves you having to work out the values yourself. So let's try the code to see if the escape button will allow us to exit the application. Our application is running. If we press escape, the application terminates. So we have correctly trapped the pressing of an escape key. So if the user presses one of the normal keys on the keyboard to fill data into the field, let's trap that and display that on screen. The first thing we need to do is to use the console command to trap the location of the X and Y coordinates on screen. You'll see why we're trapping these in a moment, but just for now, let's just print the data the user's put in on the form. Again with a standard conprint statement, remembering to put the semicolon at the end of the string to ensure we don't put a new line on screen. If we run that code now, it is now quite happily allowing us to key values in on the screen. But it's going beyond the actual form. So we need to ensure that the user cannot type beyond the end of the actual field. One way of doing this is to use the conscreen char command. It takes two parameters, the X and Y coordinate, and will return the ASCII value of the character that's currently sitting in that position. We can then use $CHR to turn this in to the normal string. So using the case statement to look for a blank character. If we try running that now, it will not let us print any text on a square bracket because it's not a space character. So how do we navigate around the actual forms? Let's assume that we want to use the tab key to actually move around the screen from field to field. As we did with the escape key, we're going to do exactly the same for the tab key. Since we know the field we're in is in the long field variable, we merely have to increment that and then use the function we created earlier to position the cursor. And if we run the application now, we can press the tab key to cycle through each of the fields. Once it reaches the last field, it will default back to the first. So this allows you to tab through the fields quite happily. So we've now started on navigation between fields. So what happens if we want to do a backspace? If we want to type something in and then backspace over it? Well, we can trap the character position using the con.cell command, and as we're backspacing, we will quite simply decrement the value of the column. And then we can use the con.cell command to position the cursor at that location. If we try that now, we can type some characters in, and as we backspace, it moves the cursor back. However, we're having the same problem. It will backspace beyond the beginning of the field, so we need to trap that. So we're going to test for the opening square bracket again. So having decremented the column position, we can test the value on that position on screen. If it is not the opening square bracket, we can allow the cursor to move into that location. Otherwise, we will put the location back to where it was. If we try running that one now, we can backspace, but it will not allow us to backspace beyond the beginning of the field. So next we want to look at how we can delete information once the user's typed it in. They may want to delete it. At the moment we can't key anything. So let's look to see how we can extend the application to handle the delete key and some more navigation. So we're now into the select statements case 2. This is our extended key section. The str input has returned with 2 characters in the variable. The first one we can ignore, the second one is the one of interest. First of all, we will pick up the delete key. In this case, this is going to be value 83. And all we're doing here is again picking up the location of the cursor currently, printing a space character to that location, and then setting the cursor at the location itself. So if we try running the code now, we put some data in, we can backspace quite happily, and if we want to lose the R letter, we can press the delete key. And the value is erased. So now we're going to do exactly the same for the right arrow, again using this same approach as we've done. We're picking up the current location, incrementing it by 1, testing the value of the character underneath the current location, making sure it's not the end of the field. If it is, we can actually move into that location. If it's not, we will move back. And very similarly, we want to do the same with the left arrow. Exactly the same approach. But this time we're looking for the opening square bracket. So let's try running the code now. So we can put some data in. We can use the right arrow, which will not go beyond the field. We can use the left arrow, and it will not go beyond the length of the field. Ideally, we want to do the up and the down arrows exactly the same way. So for the up arrow, we're making sure that the line above the line we're currently on actually has a field in it. So we're testing for the presence of the square bracket. If there is a square bracket, then it's a field we can actually move into. If there's no square bracket, we'll keep the cursor where it is. And we'll take the same approach for the down arrow. In this case, we're incrementing the row pointer, testing to see that there is actually a cursor on that field, and allowing the user to move down. If we try running now, we can use the down arrow to move up and down the fields, the left arrow and the right arrow to move left and right. We can type data in, we can backspace over it, and we can press the delete character. However, the functionality still missing is we cannot overtype a character that's already there. We would have to press the delete. This is because in the section that handles the normal key presses, we're testing for a space character. So we'll need to amend this to make sure that it handles in the same way as the closing and opening square brackets. So if we amend this case statement to handle the opening and closing brackets, if that is the case, then we do nothing. Otherwise, we print to the screen. If we try running that code now, it will allow us to key in quite happily. We can move our cursor using the arrows or the tab keys. We can backspace and delete any characters we want. So in summary, what we've seen today is we can use the console compiler to create a generic form in a text file. This can be loaded into the application and can drive what appears on the screen. The user can also navigate around each of the fields on the screen, limiting their input to the fields themselves. We have trapped many of the keyboard navigation buttons to allow the user to move around from field to field, to backspace, to delete, and to overwrite data within the field itself. This is by no means a complete form design application, but it does show the basics of how this could be achieved. Hopefully you'll find this code useful in your applications. That's it for today. Thank you for watching.